And one of the things that I love is cake. And cake is really good with frosting. When you're baking a cake, if you pull it right out of the oven, the frosting doesn't stick very well. It makes a big mess if you frost it right then. So most recipes tell you to wait about 45 to 60 minutes for the cake to cool before you frost it. So I wanted to know what the temperature of the cake was when you frost it most likely. So I used Newton's law of cooling. T of T equals T sub s plus T sub naught minus T sub s times e to the negative k T, where T sub naught is the initial temperature, T sub s is the temperature of the surrounding medium, the little t is time, and k is the constant. So I found 3 delicious cakes. The first one is extreme chocolate cake from allrecipes.com. The recipe called for an oven temperature of 350 degrees. The room temperature, which would be the temperature of the surrounding medium, I put at 69 degrees for this cake. And I set it cool to about 180 after 20 minutes. And I wanted to know the temperature after 45 minutes. So first, when you want to solve this, you want to find k, the constant, first. So you would use these facts right here, and you would go 180 equals 69 plus 350 minus 69 times e to the negative k 20. It took 20 minutes to cool to 88 degrees. Now, when you simplify this, you go 180 minus 69, which gives you 111. 350 minus 69 is 281 times e to the negative 20k. Then you would divide by 281. You get 111 over 281 equals e to the negative 20k. And now you would use the natural logarithm to get rid of this number e. So you would take the natural log of 111 over 281 equals negative 20k. Then you would divide that by k, and for k, you would get about 0.05 degrees, 0.05. And so that would be your constant. So now you have to figure out the problem for after 45 minutes. So you would go back to your equation. You would put t equals, again, 69 plus 350 minus 69 times e to the negative 45, or 0.05 times 45. And then this, you can put it into your calculator, and the temperature will be about 99 degrees, rounding off to the nearest degree. So your answer would be about 99 degrees after 45 minutes for this cake, an example of this cake. Now for the second one is a red velvet cake, which is one of my favorite cakes. This is a recipe off of foodnetwork.com, and it again calls for the oven temperature of 350. This time I put the room temperature warmer at 72 degrees. And said it cooled to 190 after 30 minutes. And I wanted to know the temperature after 60 minutes. Erase everything here. And one of the ways you can organize this data is into a table. So you can say, this is time, and this is temperature. So when you pull it out, so at time 0, it would be 350 degrees. Then for this example, I said it was going to be about 30 minutes to have it go down to 190. And then you want to know after 60 minutes, what's the temperature? So then you would go back And do the same thing that you did on this last problem. So you would do 190 equals, so it would be 72 degrees plus 350 minus 72 times e to the negative k of 30. So then, using your calculator, you would solve this. So 190 minus 72, 118 equal, and 350 minus 72 is 278 times e to the negative 30k. Then you would divide by 278. So 118 divided by 278, and the fraction would simplify down to 59 over 139. Give you would equal e to the negative 30k. And again, you would take the natural log. So you would get the natural log of 59 over 139 would equal negative 30k. And then dividing by negative 30, k would be approximately 0.03. So the constant for this one is 0.03. So then again, you go back up to your equation, but use k and plug in the rest of your numbers. So you're wanting the temperature now of 72 plus 350 minus 72 times e to negative 0.05 times 60. You want to know the temperature after 60 minutes. And here you go. The temperature would be about 118 degrees. So for the red velvet cake, it would be warmer than the extreme chocolate cake, which the main part would be the 72-degree room temperature, and this is estimating the temperatures overall. So the final one is the s'mores layer cake, which sounds delicious to me. In this one, I'm going to graph. So this recipe from delish.com calls for 325-degree oven temp. I said the room temperature was 70 degrees. I said it was 150 after 30 minutes. And I wanted to know the temperature after 50 minutes. So the first thing I would still have to solve for k first before I could put this into my calculator to graph. So I'm going to put 150 would equal 70 plus 325 minus 70 times e to the negative k times 30. And then solving this, I already done the math, and you get k to be approximately 0.04. So then you have to make an equation that you can put into your calculator to use. So you want to know the temperature would be 70 plus 325 minus 70 times e to the negative 0.04 t. Because you can use this one to find the temperature after any time. And to put into your calculator, this would equal y. So you just write it out. And then the little t you would put into your calculator is x. So over here I used a scale of 0 to 60, and this is time. And then this is about 69 degrees, so just under the room temperature I said at 70. And it's a 360 degrees, which is above the temperature of the oven. And it gave me a graph approximately that looks like this. More looks like a lot better on your wrapper than I can draw. But to solve it, so you want to know after 60 minutes, you want to know this point right here. So there are multiple ways to do this, but my favorite way is if you hit the trace button on your calculator, and from there you can just actually go on to about 50 minutes, so you want to know it right there. But, and then if you hit trace, and then you put in 50, and hit enter, you get when x is 50, y equals 104.5105. And that's a pretty big decimal, so this is the time again, and this is the temperature. So rounding to the nearest degree, you would get the temperature would equal about 105 degrees. So now you know that for all these different cakes, the approximate temperature after this amount of time. Again, the temperature varies greatly by the room temperature and the temperature of the oven and how long, of course, you want the cake to cool. But now I'm really hungry, so I really want to go eat a cake now. So I kind of want to know, I actually want to test this and see the actual temperature of the cake I'm going to make next. So, thank you. Bye.